I'm Keyvan Azami from Google. I'm an engineering manager, and I focus on solving business problems for Google's own day-to-day operations using ML. I lead a team that's been doing this for quite some time, 8 years or so, so before Gen AI was in everybody's minds. And what I'm hoping to do today is just walk you through some of our experiences and hopefully let you take away some insights about how to apply ML in sort of day-to-day life, how to deal with the uncertainties that it brings about. I might not bedazzle you with the greatest in ML. You can get that, from Google I/O, Cloud Next, and all those places. But I find that there's a different approach to applying ML to real-world solutions that sometimes is that muscle hasn't been developed in all of our teams so far. Nobody gave me a clicker to move the slides forward. Trouble two. There it is. Thank you. Thank you. Appreciate it. So our mission, applied AI research as enterprise competitive advantage. What we do is work with Google Research, specifically Google DeepMind, and look at what are the relevant capabilities that they're working on that could enhance our business functionality. So we work with different pillars at Google: finance, legal, HR, technical support, et cetera, and kind of find those solutions that could make sense. So I'm going to walk through a case study that we worked on a few years ago and kind of just talk you through some of our processes, some of the challenges that we came across, and how we overcame it. And hopefully, this would be interesting and useful. So just to kind of set the scene, Google, as you might guess, has billions of users across their products, such as Search, Maps, YouTube, Cloud, et cetera. And we have, I think as of the last financial statement, it was 180,000 employees plus X amount of extended workforce. So these folks, generate millions of inquiries every year for IT support, systems, hardware, software, et cetera. And what we want to do is to get people answers faster and make both our support staff as well as our Googlers more efficient. The self-service automation goal is identify critical self-help areas and sort of make that as intuitive as possible, as accessible as possible. And with this project, my team was tasked with surfacing relevant support articles to internal users when they raise a ticket. So they raise a ticket, don't wait. If they can find a solution for it, automatically make a recommendation, link them to the help article, and let them get the problem solved sooner than later. Our general ML lifecycle is a little bit different to traditional software development. We start with ideation and prioritization. Data acquisition, data exploration is a big, important phase for us, and I'll walk you through the details of that. And then we have prototyping, and you might see some interesting turn of events here where we don't actually follow a linear path to get through this because the nature of ML is iterative, and there's a lot of experimentation that goes on. Ideation and prioritization. So what is a business problem? We start with that problem. Okay, I know it's very tempting to think that the answer is generative AI, no matter what the question is. Well, start with the problem. What is a business problem that you're trying to solve? And kind of assess that on its own merit and look at the complexity of the potential solution and the possible impact. So we'll lay out the different ideas, we'll lay out the impact and lay out the complexity, and we sort of start focusing from the top. So article suggestions, so finding support articles relevant to the problem at hand. What's the business impact? Tens of thousands of hours and efficiency gains for Googlers, for support staff. Is ML a good solution to the problem? Do we have enough data? What kind of data it is? What type of problem are we trying to solve? What's the risk tolerance for the users, stakeholders, the support organization. What happens if we get the answer wrong? That's an important question because ML is probabilistic. If somebody says, I need 100% guarantee that you give me the right answer, I can't do that project, right? We have to be able to deal with that uncertainty in the process. And can we measure the success? Are there metrics available so we can know whether we've actually achieved the goal? And the answer was yes. So data acquisition, what do? We looked at our support data. We had millions of resolved tickets. About 10% of them were linked to an article. So somebody raised a question such as, I can't remote into my machine. And they waited a couple of hours, and one of the support staff came on board, saw the ticket, and responded with a link to the article that solved the problem. We want to automate that 10%. That's tens of thousands of tickets that could be solved. What data would we want? We want validated responses. We want to look at the tickets that were solved and had an article linked to it. So finding those is really critical. Data exploration. We spend quite a bit of time here, so we don't jump into the solutioning. It's like, what are we actually looking at? So we claim that we have these tickets, and we claim that we have these articles. What do they look like? What is the relationship between them? So we use, in my team at Google, we use Google Colab quite a bit. There are a lot of other solutions out there, Jupyter Notebooks, et cetera, where you can kind of pull your data and have different illustrations to kind of help you understand the relationship between the features that you're trying to kind of map to each other. And this is where I think this is more than an engineering task. This is where we find UX researchers come into play, where our product teams can come into play. They can help identify these relevant, important capabilities that we can kind of draw from the data. So the tickets, titles, descriptions, links, and the articles will have, again, a bunch of text, titles, and descriptions. So it's a big language problem that we have to solve for. And obviously, we know that there is this issue that we can only solve 10% of the data, 10% of the tickets. So model prototyping. Okay, so we have some data. We've looked at this, and we're like, okay, let's start like with the hypothesis and see if we can solve it. A typical approach is something called a dual encoder. You take the two articles, the two things that you're trying to map to each other, the tickets and the articles, and you develop a model, you build a model that codifies these two documents such that if they're related to each other, the code between them will be very similar. Details are not that important in terms of how that works. You can always look up dual encoders, and there's tons of literature out there. But we start with this. Like, let's see if the solution works. We start with even a very simple algorithm, TF-IDF. Again, look it up if you're interested, but basically look for frequency of meaningful words in the documents that you're looking at. And then we can move on to more complex stuff, embeddings, contextual embeddings, et cetera, et cetera. And we run this model, we train this model, and we look at the results. Precision 40%. Out of all the tickets that the model recommended an article for, only 40% of them were actually correct. The other 60% recommended the wrong article. And what's worse, recall. So 15%, what does that mean? It means that out of all the tickets that could have had an article associated with it, we only recommended 15% of them with an article. So we missed out on 85%. So the results weren't great. Right? It was like, okay, but this is where the iterative nature of the work kind of comes out. You start asking, does the model not perform well because of my features? Do I need more information about the problem that I'm trying to solve? Does the model not perform well, but there is room for experimentation? Can we try other techniques? So we started with dual encoder and some language techniques, but are there better solutions to this? And what's worse, did I even think about the problem right? Have I framed the problem correctly? And then here's where you're like, uh-oh, I thought I was moving forward. But no, we go back and forth. So this was the life cycle that I described, and we actually work like this. we go back, we look at the data, we look at the idea again, and say, okay, how can we kind of improve this? How can we make this more appropriate? And again, this is where the interaction between engineering, product, UX becomes quite important, because that problem framing stage is where you're trying to understand how you're solving the business problem. So ideation prioritization, again, focus on the impact we're trying to achieve. What are we trying to do? Do we really need to suggest from the long tail of articles? So we've got a lot of articles, tens of thousands of them. Do we actually care in the first instance that every one of them is looked at for each ticket? Maybe not. What we need to do is focus on an 80-20 approach. If we get 80% of the tickets resolved with the sort of the most common articles, that's still a win. Can we simplify the problem? And then this is where we reframe the problem differently. Instead of finding an article, we say, actually, we're going to classify it. We're going to say, here are the most common problems. And for a ticket, we're going to say, which class, which type of ticket, which type of article does it relate to most? And different method, different technique. And focusing on returning the right article. So, we start looking at, if you remember, we looked at that precision and recall, 40% precision, 15% recall. What we focus on is, let's get the articles right. Even if we miss the opportunity, the ones that we do try, let's make sure the answer for those is right. So at least we're helpful and we don't send people the wrong direction. So we start back in the prototyping phase. Tickets. We try to identify the articles. Let's say we find 1,000 articles, and we start mapping them. And we train a model to try to guess which article would be most relevant. Language modeling, as we talked about, we start getting better results. Not perfect, but better. 50% precision, 25% recall. We're getting more accurate. Still not good enough. So what's wrong this time? Does it not perform well, but is there room? So we're still short of the goals, time to debug. We start engaging with the stakeholders, the partners. So that, again, back to the iterative nature. Bring them back in, let them see, let them weigh in on the problem and the solution. So we show them some examples. A ticket comes in, the model says X, and in the data, actually, there was no article that would have been appropriate. So the feedback is, that seems like a mistake. We do the same thing again. They kind of understand it. We do this again. And they start seeing that actually there's a labeling issue. They haven't, all the data we were looking at initially and looking at tickets that were resolved and there was an article, it wasn't always correct. There were some false positive in there. There were some tickets that were linked to the wrong article, which we didn't anticipate initially. So we go back, data acquisition. So here we work with the partners and said, okay, what if we actually run a labeling exercise? We take 2,000 tickets, we take a bunch of them, and then have your expert staff label them. Make sure the articles are correct, make sure they're linked correctly, so that when we're training a model, it's learning from correct information. So sort of the old adage of garbage in, garbage out, right? So we're going to clean that up. And surprisingly, even with 2,000 tickets, you can make a dramatic improvement. So we start prototyping again with this label data, and we try a bunch of different ideas. And we start seeing significant improvement. We get to 80% precision. That's really good. That's really good in the ML world. We can work with that, right? And recall is improving, but that's okay. We're like, get 43% of the problem solved that could have been solved, and with 80% precision. That's a solution that the stakeholders can work with. But it's important to engage them at that level, because it is ultimately, when it gets wrong, somebody's going to complain. Hey, you sent me the wrong way. And they need to be comfortable that the benefits is worth sort of the occasional pain and escalation that may happen. And then the hard part, model productionization. So we spend all this time looking at data, building the model, but actually to make a solution, put it in production, and make it an industrialized solution, you need a lot of different pieces. And the ML code is a small part of it. So we have all this apparatus that you have to put together. You obviously, larger organization will have their own, their third-party solutions, cloud solutions across all the typical vendors. But this is where you kind of have to put it together and kind of make it work as a real software would. Monitoring and maintenance. Now here's the problem. So we looked at tickets at a point in time. What if things changed, right? So COVID happened, and the problems were different. People were complaining about different type of issues. We were working remotely. There were much more remote-oriented questions and issues. So you start seeing actually a drop in the quality of your model. It doesn't often find the articles that it needs. It starts sending people down the wrong way. More often, that precision drops. So you need to be able to measure this. You need to have tools, dashboards, reports, whatever it is, some way of metrics. You don't need to do this on a day-to-day basis, but at least on a quarterly basis, if not more frequently, so you can have you can feel whether the solution changes. So in traditional software development, you have regression when you change the software. Well, here you have regression even if you change nothing. The data distribution in production changes. So you got to keep an eye on that. And that's sort of what we call model drift. And you'll have to have retraining. You could have continuous training cycles that will help you. So takeaways and other considerations. Have a structured approach to machine learning projects, right? So it's very tempting to say, hey, just give me some data. I'm going to start prototyping this. And this is where I think product teams are quite important, because you can kind of ground the engineers a little bit more as well. Think about the problem, frame your problem correctly, think about the different approaches that you could take, think about the users, and this is kind of, I failed to mention how much of our focus is on sort of human-in-the-loop process. How do we make sure that this automation is not sort of people versus machines, it's people with machines, right? It's an assistive technology, not sort of an independent automation. So be ready to iterate and ask questions, that's okay. And we can fail fast, by the way. So those diagrams that you saw, be okay with getting to a point that says, well, you know what, the precision and recall is just not good enough. We're going to abandon this project. And the sooner you do that, as opposed to sink in many months of iterative work only to get like marginal improvements, and celebrate those failures. There's in my book actually not failures, they're experiences that you've gained. And we have developed a high tolerance for that type of thing, because we want to encourage experimentation, but we want to fail fast so we don't waste too much time. Leverage the right tools for the job. ML has different tool sets, so you look for them, research them. There are a lot of good opportunities. The space is improving quite fast as well. And look at the impactful problems that are fit for machine learning. The first question is, can I solve this problem with a rule, with a rules-based approach, with heuristics? If you can, that's where you should start, not with machine learning. That should be the next step. Develop a baseline so you can build on top of it. So that was our case study. We have a few minutes. I'm happy to answer any questions if there is any. But also, folks can always reach out offline too.
Awesome. Let's give them a round of applause. Questions? Right on time. That's perfect. We're seeing something weird here, so we're gonna look there. Here you go.
Awesome.
You know what? There's no questions submitted online. Anyone in the audience have a question?
Thank you for sharing your work. For this article surfacing ML project, can you share how you worked with a UX designer? What was good and what can be improved?
Yeah, great question. The question is, how do we work with the UX designer in this project, right? So think about from a user perspective, whether it's a Googler or a support agent, what do they see? So the questions for us was, when they raise a raise an issue, how do we reach back out to them? How do we provide the interface, the sort of feedback? So the question is like, do we send them an email? Do we help the agent and then have the agent validate before we send that? Would that kind of create some delays? Do we add the article directly into the ticket and hope for the best? So those were some of the consideration that we were working with our sort of UX partners. There were future phases of this project where we had more real-time interaction. For instance, when they're actually engaging an agent in real time, where I think the user experience was a little bit more dynamic. So thinking about how do you surface relevant articles as the chat goes on. So for instance, here we talked about a ticket mapping to an article, but if you have a live chat and constantly like the model is monitoring the conversation and says, now I understand what they're talking about, it's probably this article. And then sort of how do you surface that was definitely a key aspect. But really thinking about like how do we want to expose the users to potential uncertainty was a consideration for the UX team.
Great. One more question from the audience. Can you elaborate on rules-based approach and creating a baseline? We have opportunity to apply machine learning, but my junior employees don't quite get what creating baseline and rules mean.
Yeah, thank you for the question. So let's say we had, this problem may not be appropriate, but the idea being that, how would you describe the solution in sort of traditional ways, with if then else, right? So if you see this type of issue, if you see the following words in the ticket, do the following thing, choose this, recommend that, or show them a list of potential articles. That would be a rule, a heuristic that you could apply because that's sort of what the human nature would be when they see that issue. So try to replicate that in code, and that will give you and the baseline here would be that, and how effective is that? So if you were to, obviously without ML here, it would be hard to kind of, match free text between articles and tickets. But if you were looking for like words and try to word matching and things like that, you could probably get somewhere, and you could look at the quality of that, the precision and recall of just that rules-based approach, a very traditional software development approach. And you probably will find that the precision may be like 20% and recall maybe 50% because you probably will try more. And that kind of gives you that baseline to say, okay, if I apply ML, can I get better than that? And how much better for the effort? So that's sort of how I think about it, business rules. Hope that helps.
Great. This is a good question that I kind of like. How do you make sure your structured approach is effective? Do you validate your approach before you start the project?
Yes, this is, there is a little bit of sort of experience from, doing one or two projects that you kind of develop. But by structured, I think even just looking at some of the blueprints that I illustrated, the steps that we take, and kind of thinking about your project in that way. So when you're trying to plan a project, it's kind of hard when somebody says, how long is it going to take? How long does it take to build a machine learning project? I don't know. I really don't know because I don't know what's in the data. I don't know what will work. So what I can do is say, okay, the following are my next activities. I'm going to look at the data, and I'm going to take 3 weeks doing that. And I may have to extend it, but at least I can have an estimate for the following tasks, right? So you can kind of break down your project that way, and then gradually kind of develop confidence around some of the abilities, right? If you've done a project with language recognition a couple of times, the third time you may be able to have a better approach to estimating it. But by just kind of breaking down the phases of it and try to time boxing it will help you manage expectations and set some goals for the team that are working on it.
Great. At what stage should the UX designer be getting involved?
Very good question. I think the UX designer needs to be involved from early on, actually the early phases. It can be sometimes tempting to say, okay, people are talking about data science and models and algorithms instead of, I can back away. But a recent project that I've had, we kind of had early involvement, but very quickly we focused the conversation on engineering. And then with the product that is developed sort of has missed the opportunity to have to think about the UX aspect of it, and so we're now backtracking. So I think early on, making sure that before you jump into what ML can do is thinking about that experience and what it is, how would that work, and just assuming that the model is not going to be perfect. The model is going to have X% precision. So how do you surface that uncertainty to the users? You can't hide it from them. You can't say to the user, here's the answer, I know this is the answer. You have to be able to leave some room, and that's the job for product and design teams, to figure out how we want to kind of manage that risk. So I think early on is the answer.
How early?
Day one. Why?
Day one, I love it.
Day one, day two, something like that. Yeah.
I love it. I think when I hear that from developers and engineers, that's just makes my day.
Good.
Love it. Maybe one more question. Was 80% of improvement accuracy just from labeling?
I mean, the labeling improved significantly, but if I go back, I don't know if I can't see it here anymore, but we actually looked at some language models. So this project is from a few years ago, so we used the BERT language model. That helped us quite a bit. It had a much more sophisticated ability to understand the context of those articles compared to the sort of the initial primitive sort of TF-IDF approach. So there is a little bit that you can gain, a lot that you can gain from improving the techniques that you're kind of using, especially nowadays with very sophisticated language models. You probably can do even better. But the labeling was important because that was your ground truth. That was the thing that you could kind of go back to and make sure that sort of helped drive the precision.
Excellent.
Okay.
Keyvan, thank you so much.
That's my pleasure.
I appreciate
Thank you all.
it. Give him a round of applause.
Thank you.
Appreciate it. Thank you.